Regarding the use of stainless steel floats with integral rubber cords in municipal sewage pumping wells, it is important to address the electrical classification of the environment. The initial mention of 120 volts and Class 1 Division 2.1 raises a concern, as this classification is not a recognized standard. Typically, we encounter Class 1 Division 1 or Class 1 Division 2, but not Class 1 Division 2.1. Assuming the intended classification is Class 1 Division 2, the acceptability of the float switch and its electrical code must be carefully evaluated. My opinion is that the described float switch is not acceptable for Class 1 Division 2 applications based on two primary reasons. Firstly, the float switch itself lacks explicit approval for Class 1 Division 2 environments. Secondly, the electrical code associated with the float switch also lacks the necessary approval for use in Class 1 Division 2 locations. Even if the float switch were certified for Class 1 Division 2, the unapproved electrical code would still render the entire assembly unsuitable for such hazardous locations. It is imperative to verify the float switch's approval status with the manufacturer. If the manufacturer confirms that the float switch is not approved for Class 1 Division 2, then it should not be used in such applications. Several resources can provide further guidance. Firstly, NFPA 820, titled Standard for Fire Protection in Wastewater Treatment and Collection Facilities, offers comprehensive requirements for electrical installations in wastewater treatment plants, including sewage pumping wells. Secondly, resources detailing electrical classifications can help clarify the definitions and requirements for different hazardous locations. These resources explain the characteristics of Class 1 Division 1 and Class 1 Division 2 environments, including the types of flammable substances present and the likelihood of their presence. Thirdly, information on electrical code classifications provides details on the types of codes approved for different hazardous locations. These resources specify the construction, materials, and ratings required for codes used in Class 1 Division 2 environments. When selecting electrical equipment for Class 1 Division 2 locations, several key considerations must be taken into account. Firstly, the equipment must be specifically designed and approved for use in Class 1 Division 2 environments. This approval is typically indicated by a listing from a recognized testing laboratory, such as Underwriters Laboratories or Canadian Standards Association. The listing mark signifies that the equipment has been tested and found to comply with the applicable safety standards for Class 1 Division 2 locations. Secondly, the equipment must be installed in accordance with the manufacturer's instructions and all applicable electrical codes. This includes proper wiring methods, grounding, and bonding. The installation must be performed by qualified personnel who are familiar with the requirements for hazardous locations. Thirdly, the equipment must be maintained in good working order. This includes regular inspections, testing, and repairs. Any damaged or defective equipment must be replaced immediately. Regarding the electrical code, it is crucial to ensure that it is suitable for the specific application and environment. In Class 1 Division 2 locations, the code must be approved for use in hazardous locations and must be resistant to the chemicals and other substances present in the sewage pumping well. The code must also be properly sized for the voltage and current requirements of the float switch. Extra hard usage cord, as mentioned, may be suitable for providing flexibility for equipment removal, but it must still meet the requirements for Class 1 Division 2 locations if it is used within the hazardous area. The use of intrinsically safe barriers can provide an additional layer of safety in Class 1 Division 2 locations. Intrinsically safe barriers limit the amount of energy that can be released into the hazardous area, thereby reducing the risk of ignition. However, even with intrinsically safe barriers, the float switch and electrical code must still be approved for use in Class 1 Division 2 locations. Terminating the float switch at terminal strips outside the well on intrinsically safe barriers can be a viable approach, but it is essential to ensure that the entire system is properly designed and installed. The barriers must be properly grounded and bonded, and the wiring between the barriers and the float switch must be suitable for use in hazardous locations. The use of unapproved equipment in Class 1 Division 2 locations can have serious consequences, including fire, explosion, and electrical shock. It is essential to prioritize safety and to ensure that all equipment is properly selected, installed, and maintained. In summary, the acceptability of stainless steel floats with integral rubber cords in municipal sewage pumping wells depends on several factors, including the electrical classification of the environment, the approval status of the float switch and electrical cord, and the proper installation and maintenance of the equipment. Consulting with the manufacturer of the float switch and referring to relevant standards, such as NFPA 820, are crucial steps in ensuring a safe and compliant installation. Always prioritize safety and consult with qualified professionals when working in hazardous locations. The National Electrical Code or NEC provides guidelines for electrical installations in hazardous locations. Article 500 and subsequent articles address specific requirements for different classes, divisions, and zones. Understanding these requirements is crucial for ensuring safety and compliance. In a Class 1 Division 2 location, a hazardous atmosphere is not normally present in explosive concentrations. However, it may become present due to accidental release, rupture, or breakdown of equipment. Therefore, electrical equipment used in these locations must be designed to prevent ignition of the hazardous atmosphere. This can be achieved through various methods such as explosion-proof enclosures, intrinsically safe circuits, and non-incentive equipment. Explosion-proof enclosures are designed to contain any explosion that may occur within the enclosure, preventing it from propagating to the surrounding atmosphere. Intrinsically safe circuits limit the amount of energy that can be released into the hazardous area, thereby preventing ignition. Non-incentive equipment is designed to not produce sparks or hot surfaces that could ignite the hazardous atmosphere. When selecting electrical equipment for a Class 1 Division 2 location, it is important to consider the specific properties of the hazardous material that may be present. These properties include the auto-ignition temperature, the lower explosive limit or LEL, and the upper explosive limit or UEL. The auto-ignition temperature is the temperature at which the hazardous material will spontaneously ignite in air. The LEL is the lowest concentration of the hazardous material in air that will support combustion. The UEL is the highest concentration of the hazardous material in air that will support combustion. Electrical equipment used in Class 1 Division 2 locations must be rated for the specific hazardous material that may be present. This rating is typically indicated by a group designation, such as Group A, Group B, Group C, or Group D. Each group designation corresponds to a specific range of hazardous materials. In addition to the NEC, other standards and regulations may apply to electrical installations in Class 1 Division 2 locations. These standards and regulations may be issued by federal, state, or local authorities. It is important to be familiar with all applicable standards and regulations before installing or maintaining electrical equipment in a Class 1 Division 2 location. Regular inspections and maintenance are essential for ensuring the continued safety of electrical installations in Class 1 Division 2 locations. These inspections should be performed by qualified personnel who are familiar with the requirements for hazardous locations. The inspection should include a visual examination of the equipment, as well as testing to verify its proper operation. Any damaged or defective equipment should be repaired or replaced immediately. Training is also essential for personnel who work in Class 1 Division 2 locations. This training should cover the hazards associated with the location, as well as the proper procedures for installing, maintaining, and operating electrical equipment. Personnel should also be trained on how to respond to emergencies, such as fires or explosions. In conclusion, the use of stainless steel floats with integral rubber cords in municipal sewage pumping wells requires careful consideration of the electrical classification of the environment. The float switch and electrical cord must be approved for use in Class 1 Division 2 locations, and the installation must comply with all applicable codes and standards. Regular inspections, maintenance, and training are essential for ensuring the continued safety of the installation. When dealing with potentially hazardous locations, it's best practice to consult with a qualified electrical engineer who specializes in this area. They can perform a hazard assessment, help select appropriate equipment, and ensure the installation meets all code requirements. Additionally, local regulations may impose specific requirements beyond the NEC, so it's essential to check with the local authority having jurisdiction. Remember that safety is paramount, and any doubts about the suitability of equipment should be addressed before installation. Consider alternative technologies as well. For example, ultrasonic level sensors or radar level sensors might be suitable alternatives to float switches in some applications. These sensors don't require physical contact with the liquid, which can reduce the risk of fouling and improve reliability. They can also be installed outside of the hazardous area, further enhancing safety. Another option is to use a float switch with a hermetically sealed switch mechanism. This type of switch is designed to prevent the ingress of hazardous materials into the switch enclosure, which can reduce the risk of ignition. The choice of wiring method is also critical in Class 1 Division 2 locations. Conduit systems are often used to provide mechanical protection and prevent the spread of fire or explosion. The conduit must be properly sealed to prevent the ingress of hazardous materials. Cable glands and fittings must also be approved for use in hazardous locations. When using intrinsically safe circuits, it's important to ensure that the entire system is certified as intrinsically safe. This includes the power supply, the wiring, and the field device. The system must be installed in accordance with the manufacturer's instructions and the applicable codes and standards. Periodic testing of intrinsically safe systems is also required to verify their continued integrity. In addition to electrical safety, other safety considerations may be relevant in municipal sewage pumping wells. These considerations include the risk of exposure to hazardous materials, the risk of falls, and the risk of confined space entry. Proper safety procedures should be implemented to mitigate these risks. This may include the use of personal protective equipment or PPE, such as respirators, gloves, and safety glasses. It may also include the use of fall protection equipment, such as harnesses and lanyards. Confined space entry procedures should be followed whenever personnel enter a sewage pumping well. These procedures typically include air monitoring, ventilation, and rescue plans. The specific requirements for confined space entry vary depending on the location and the type of hazardous materials that may be present. Remember to always prioritize safety and to consult with qualified professionals when working in hazardous locations. The information provided here is for general guidance only and should not be considered a substitute for professional advice. It's essential to stay up to date on the latest codes and standards and to follow all applicable safety procedures. The consequences of non-compliance can be severe, including fire, explosion, injury, and death. So take the time to do the job right and ensure a safe working environment. Lastly, document everything. Keep records of equipment certifications, installation procedures, inspections, maintenance, and training. This documentation can be invaluable in demonstrating compliance with codes and standards and in identifying potential safety issues. Regularly review your safety procedures and update them as needed. Continuous improvement is essential for maintaining a safe working environment.